All right, so this begins the topic of word problems, and the book in chapter 1, section 6 and 7. If you'll look very carefully through the instructional part of the book and then in the problem-solving part of the book, each of those sections is that the problems match a particular type of problem. The problem in the homework section matches a type of problem described in the instructional part of the section. So, for instance, in section 6, you'll see a type of problem, and it's listed out here with the big green number 1. I don't know if you can see that on the video. And then that's a type problem that they refer to in the homework section as a type 1 problem. And so if you look over here in the homework section, it will say that you are to follow, see example 1, object 1 for these sets of problems. And then it will get to the next section, it will say see example 2, object 2. And that's very helpful because many of the problems follow almost exactly the pattern that's provided in the example that goes with it. And I'll just give you one of these problems as an example, and then I'll do another one in this chapter, and then I'll do 2 problems for chapter 1, section 7 as well. And then for our online class for Friday, January 26th, I'll solve a couple more problems, and then you'll be required as part of that online class that day to work a problem from the book and post your solution to that problem in the discussion board. So that class, that Friday, January 26th, will meet online where you'll watch the video, then you'll solve your assigned problem. You can write it out, take a picture of it, post it to the discussion board, however you wish to solve that. So for the next 3 class periods, the focus will be primarily on these kinds of solving word problems for the next couple of 2 or 3 classes. So this video is for section 5 word problems. And the first type of problem is where you have something like this, 213 feet of rope, and you're being asked to cut it into 3 not equal pieces. That would be pretty easy. You would divide 213 by 3 and you would be done. And 213, it does divide evenly by 3, so you'd be done with it. But instead we're told instead of 3 equal pieces, each is 2 feet longer than the next one, than the one before, than the previous. Whoops. And so on that, we would say, well, this first section of rope, using algebraic equation to solve this, we'll set that to length x, which means the second strand of rope, the second length of rope would be x plus 2, and the one successive after that, each one 2 feet longer than the previous, x plus 4. Now what you have to be careful about in these word problems is to make sure you answer the actual question that's being posed. Because sometimes I'll see a student solve all of this, and the question may ask something like, what is the length of the longest piece of rope? Well, they get to the end, solve for x, and they'll write down the answer, and what they've given is the answer to the shortest piece of rope. So always carefully read the instructions, the directions, so that you're sure to solve for what's actually being asked. And so in this case, the question reads as follows. Where should this person make the cuts? Okay, so that's a different question altogether than what's the length of the first and the last. So we're being asked, at what point along the rope do these 2 cuts occur to break this rope of 213 feet into 3 pieces, each piece 2 feet, successive pieces 2 feet longer than the one before. So now, setting this problem up, what we know is that this piece plus this piece plus this piece equals 213 feet. So x plus 2 plus x plus 4 is equal to 213. And now, following the normal algebraic approach, we have x plus x plus x, that's 3x, plus 2 plus 4 is 6, equals 213. Subtract 6 from both sides. This gets us 3x is now equal, 213 minus 6, 207. And 207 divided by 3, let's see, that is 69. So x is equal to 69. X plus 2 would then be equal to 71, and x plus 4 would be equal to 73. But that's not the question. We're not asked how long are the pieces of rope. We're asked where are the cuts going to be made. The first cut will be made at 69 feet. And then the second cut will be made 71 feet later. So 71 plus 69, that's 140 feet. At 140 feet of rope. So 69 feet and then 71 feet later, 140 feet. That's where the two cuts would be made. And so the answer to the question is to this is we would cut it at 69 feet. We'd cut it 71 feet later, or at 140 feet, and then that would leave us with 69 feet, 71 feet, and 73 feet of rope. All right, so that's how that problem is done. That's not a hard problem, and we will have a problem like this on the test, something like this. I think this is a very simple problem, and I think it does reflect, though, taking words on a page and translating them into algebraic equations. Now, I mentioned to you that math has sentence structures just like normal grammar. It's symbolic, it's writing. So if you say, for instance, a number 2 greater than the one before, we have a number, and we have a number 2 more than the one before, x plus 2. That's a sentence. We're working on constructing a symbolic sentence to take those words written on a page in normal English grammar and translating them into mathematical sentences that make mathematical sense. So there's key words here then. Each one is 2 feet longer. Well, that's a plus 2. If we said each one was 2 times longer than the one before, we would have 2x, not x plus x. And so if we said each one was 2 feet less than the one before, we'd have x minus 2. So what we want to do is take those normal English verbiage and convert it into algebraic sentences. And that's really what we're after in the use of word problems. Now let's take another example here. This one comes from the world of geometry. This one comes from geometry, and so it's very common in geometry to ask questions about triangles. And the reason for this is triangles have lots of really nice features. For instance, right triangles, you have the Pythagorean theorem, a squared plus b squared equals c squared. We also have the situation where the angles of a triangle, the sum of the angle measurements of the triangle is 180 degrees. This is fairly common knowledge and can be very helpful. So in terms of a lot of mathematical principles, the concepts of triangles are used in all sorts of engineering problems and architectural problems. And so the book has a word problem involving angles of triangle. We're told that the vertex angle of an isosceles triangle is 64 degrees. Now, isosceles triangle, you have to see the definition of that on page 65. An isosceles triangle is such that these two sides are the same, and this one may be different, or is often different. Otherwise, we'd have an equilateral triangle. And so, on an isosceles triangle, we're told that this angle here is 64 degrees. And in an isosceles triangle, since that length and that length are the same, these two angles here and here are actually equal. So if we refer to this as the as n degrees, then this must also be n degrees. What we have here then in terms of algebra is setting this up. The sum of those three angles must equal 180 degrees total, because all triangles, the sum of the three angles sum to 180. This 180 degrees then is 64 degrees plus n degrees plus n degrees. That would be maybe a way of setting that up. And so if we go to solve this, we would have 2n equals, and we subtract 64 from both sides. So that would be 56, 64 from 180, 1 and 6 from 80 is 2, so 116. So n then would equal 116 divided by 2, divide both sides by 2 to get n by itself. 116 divided by 2 is 58 degrees. And now we can check this pretty easily. 58 plus 58 plus 64. Does that equal 180 degrees as is required? And what we'll find is if you add these up, that they in fact do get us to 20. That equals 20. And then 180 degrees. And so that in fact works. So those two angles are 58 degrees. Now let me go back and check to make sure that's what we're being asked. The question is if the vertex angle of the isosceles triangle is 64 degrees, then we're asked this question, find the measure of each base angle. So we have solved it. The measure of each base angle is 58 degrees, and that's how that particular problem is done. And that's problem type 3, the example number 4. But if you'll look in your book, you'll see this big green number 3 out here, and that lets you know it's problem type 3. So then back in the homework problems, you'll see that there's a little header above that says see example 4, object 3, the 3 corresponding to that little green square back in the example section, explanation section of the book. And so now these problems will follow that. And some of these problems will use triangles, some will use a four-sided object, which those sum not to 180 degrees, but to 360 degrees. There are other problems like that where you will piece the missing information together like this and solve for a missing angle. So those are two types of problems from Chapter 1, Section number 6, the first of the two sections on word problems in Chapter 1.